Section 3, Swyk 2. All right, so natural log of e to the 77th. Now, to be quite honest, folks, this is going to be very easy for you. But it's ready for me to change to its exponential form. We know that because we're dealing with natural log. Down here is my base, and that is e. Do not get confused. This thing that I just circled in red is not a part of the base. The base goes with ln. We know that the exponent is x because we know that logs equal exponents. The argument is e to the 77. Now, look at what you have. You have e to the x equals e to the 77. This should be real easy. The bases are both the same. We know they're equal. Therefore, x has to be 77. In other words, they gave you the answer. Isn't that nice? But I need you to understand what you're looking at, not just, oh, okay. By the way, that same thing would be true if the question was log base 2 of 2 to the 5th. The answer to that would be 5, okay? If the base of the argument and the base of the log match, then the exponent is given to you. Ta-da, you got the answer. Okay, question 9, getting into the compound interest stuff. I know that we beat this into the ground earlier, so I'm just going to kind of highlight what we're going to use the formula for and what we see. You're either going to use the compound interest formula that does not involve E or the one that does involve E. The one that does involve E is looking for a phrase compounded continuously. Okay, and if you don't see that phrase compounded continuously like you do down here, then you ain't going to use it for that. Okay, you're going to use the other compound interest formula. Okay, what is the accumulated value if the money is compounded semi-annually? Now, we talked about how semi-annually meant 2 times a year, right? We start with $15,000. The interest rate here is 5.5%, which we convert to a decimal, 0.055. 2 is the end value, which we know appears twice in the formula, and 7 years is the time frame we're given. You type that into a calculator, I guarantee you get $21,929.91. So, now some of you probably need to use parentheses around that exponent in order to get it right. Unless you already know it's 14, then you could just type 14. But if you don't want to mess with that, you could just put parentheses around it and move on, especially if the numbers are getting larger or more difficult. So, compounded monthly, that doesn't say continuously, so we're going to use the normal compound interest formula, but the end value is now 12. Okay, remember how we use parentheses around the exponent? And we end up getting $22,024.83. So we get more money because the compounding factor went up. Our money sat in the account the same amount of time, 7 years. The last one is the Pert formula, right? It's a nice, clean, shampoo-like formula. I don't know if you guys even know what Pert shampoo is. That might be an old brand. Anyway, so this one has the phrase compounded continuously. That means that you're getting these little tiny pieces of interest, but you're getting them all the time. So much so that it's continuously building interest. Now, that is the absolute fastest way to grow your money. Okay? And in this case, 5.5% interest for 7 years would kick out $22,044.21. Now, I'm not saying it's a huge amount of difference, but it is a difference. And if you started out with $150,000 or $1.5 million, it would seem like a significant difference. Or if you gave it a lot more time, you would see a significant difference. Question 10. Okay. The value of a particular investment follows a pattern of exponential growth. Okay. In fact, they tell me that the formula that it follows is the Pert formula. They want to know, when will the account be worth $11,738? So that's the A value. So I put that on the left side. They gave me an interest rate of 6.6%. They want to know how much time it will take and in what year will it make that happen. All right. So the first thing we got to do is get rid of this. Got to divide. You can't multiply 7,900 and e together because they don't have the same exponent. So divide that 7,900 to the other side. So that gives me this 1.486 number. Yes, I know that's a rounded value. So then I'm going to change it to its log form, right? Natural log, right? Because it's base e. The natural log of 1.486 is equal to the exponent 0.066t. Therefore, I can divide by 0.066 and be done with this question. So you need to type this in your calculator and it will spit out 6 years. Now, 6 years from what? We started off in the year 2000, therefore 6 years from the year 2000 is 2006. Yeah, I know I'm going through this a little bit quickly, but you've been through enough of these log questions, it should make sense. 11 looks more complicated, but it's not really. However, this one is a little bit, it's very similar to the last question. So we're starting with 10,500. We want to know when you get 20 grand. 7% interest, so I had to put that in the formula, 0.07. It is compounded 4 times a year, so this is not the Pert formula. This is the regular compound interest formula. So for 4 years, or no, I shouldn't say for 4 years. We're trying to figure out how many years there are. The compounding factor is 4. So first thing we did was divide out the 10,500. Move that to the other side. That gave us the 1.905. Change it to its log form. The base is weird, 1.0175. I don't know how to do that. So we use the change of base formula. And once we do that, then we divide by 4 and we come up with 9.3 years. 9.3 years, they did say round to the nearest to 1 decimal place. So that's the process that you would need in order to figure that out. Question 12. This one, it starts out similar, but it is different, okay? This time they gave me the time, but they're asking me to find the interest rate. So we have 180 now I don't have a cool name for that. 180 times a year. That's every other day, pretty much, okay? So we're starting out with $900. We want to know when it grows to $1,300. So I put in the 180 for n, and I put in the 4 for time. But I know what 180 times 4 is. That's 720. I'm going to zoom in on this because it's a little bit different. Several of you would look at that and go, oh, we need to change it to logs. This isn't a log question. Logarithms are only needed if you don't know the exponent. But clearly, we know the exponent is 720, right? So how do we get rid of the 720th power? That's right, folks. We take the 720th root. You got to use a calculator for that because that's ugly. 720th root gives me this weird number, 1.0000051, blah, blah, blah. So first thing I did was I subtracted a 1 from both sides, right? Took a 1 away there and then 1 away there. That gave me 0.00051 equals r over 180. Of course, I multiplied by 180 on both sides, right? Multiply by 180 on both sides. And when I did that, I got my answer of 0.0918, which can be converted to a percentage by moving the decimal 2 places to the right. So, as to the 10th, that would be 9.2%. 9.2%. Question 13 is a Pert formula because they use the phrase compounded continuously. Okay? So, we start out with 8,500. We want to know when it changes to 17,000. Yes, I know that's doubling. We're getting an interest rate of 4%. We don't know how much time it's going to take to do that. So we set up the formula. The first thing we do is divide the 8,500 to the other side because you can't multiply 8,500 and e together because they don't have the same exponent. Okay? Then, since we don't know the exponent, change to log, and since it's base e, we go with natural log. Natural log of 2 equals the exponent 0.04t, divided by 0.04, 17.3 years. Going to take a little bit of time to double that at that low interest rate. But if you got the time, you can double it. Okay, 14. Let's see here. This should be the last one. Yes. Okay. So 6,600. What we want to know. We're starting with 2,200. So we want to know what interest rate would allow me to triple my money in 7 years. Triple my money in 7 years. So of course we divided the 2,200 to the other side, and that gave us 3. Now that we have the it's set up in this form, change it to its log form. The natural log of 3 equals the exponent 7r. We can divide by 7, and don't try to do the natural log of 3/7 because that's not going to give you the same answer. You better be checking these to make sure you can type them on a calculator correctly. The natural log of 3 over 7 like that gives me 0.1569, which rounded to 1 decimal place is 15.7%. Whoo! What a busy week! All right, they're all done. Get the assignment done, get the test done. That's a lot of work.